Hi everyone, welcome to Spare Course, where we help save cloud costs by finding the best cloud service. Gergely is also joining me today. Hey Gergely.
Hey,
Let me ask you something, Gergely. When an engineer needs to pick a cloud instance, where do they go first?
well, an obvious choice is heading straight to the cloud provider's homepage or their console, right?
Yeah, but here's the thing, if you really think about it, cloud providers make money when you spend more on their services. So are they really incentivized to show you all the best deals? Or are they gonna even highlight the most cost-effective options?
Well, that's a brilliant point, Amy. At Spare Course, we realize this potential conflict of interest, and our mission is to be your independent guide, helping you find the most cost-efficient and performant instances across all the vendors out there, so we save money for you and get better performance at the same time.
So today we're actually going to show you the stark difference between picking an instance in the traditional way in the cloud console versus using the actual performance data to make smart decisions, aka finding the best deals for cloud servers. Gergely, let's start with the AWS console then. So I need a AWS instance for an AI pilot project with at least 4 gigabytes of memory. Gergely, can you show me what most engineers see when they use AWS console?
Yeah, I've already logged in here and scrolling down, you can see the list of instances. And while loading this takes quite some time, there are like 1,000 different instances. You have the option to filter for some of these here, but going to their compare page makes probably more sense where you can filter for, let's say, okay, we need 4 gigabyte of memory and you
Hmm.
see all the related instances. But well, the information points are like number of vCPUs, and there are huge differences between vCPUs, right?
Hmm. So what's really missing here that are critical for picking a good instance?
Well, the actual performance, it's like you're buying a car based on the number of seats and doors and maybe the engine size, but you have no idea how fast it can actually go or about the fuel efficiency. Just looking at, for example, the network performance, it's like low to moderate or some up to some numbers. We do actual measurements and share that on our side.
Mm. And of course, AWS defaults you to their newest or could be the most expensive instances. They are not exactly incentivized to show you the last generation instance, but that might be a good deal, 50% cheaper with 90% of the performance. That's really what we're looking for as engineers.
For sure, like price and price per performance is not even shown on this screen. So let me switch to spare cores and how you can look up the related servers using
Yeah,
our
they
site. So
probably A/B tested and see they shouldn't show the price on the page. Yeah, so this is the spare core page, right?
I just filter for AWS. So we are looking at that single vendor and we want to filter for machines with at least 4 gigabytes of memory. So
Hmm.
uh, here's a quick view. You can see that we do have a bunch of servers as well, but we do have some performance data as well.
Hmm. Instead of just seeing basic specs, we're seeing instances ranked by price performance, efficiency, with actual benchmark data. And this data is real time, right?
Yes, we are updating the prices every 5 minutes. If you're interested in the spot price or on-demand price, you can find that here and you can reorder as needed.
Hmm. So these results are ordered by the best deals. Is that how we should be
Yes.
using it? Yeah.
Yes, currently it's ordered by the best price, which defaults to spot. Uh, but we also show performance data and the cost efficiency related to the selected benchmark.
This is great. Everyone loves great deals, and especially me. What am I looking at here in terms of real performance difference? Can you show me how to compare them?
Yes, so by default, we are looking at a single benchmark score, but we are benchmarking for 500 metrics each server. So let's say we are interested in comparing three generations of the R instance family. So I'm selecting R6, 7, and 8, clicking compare. Now we are just focusing on these three instances.
Mm.
You can see the price differences and many more.
So for the memory bandwidth comparison, is how fast we can process the actual data, right?
So in this chart, you can see mixed read and write operations using different block sizes. And to keep it simple for now, here you can see that if we are focusing on, let's say, 1 megabyte read-write operations, we can reach 27 500 megabytes per second with the oldest generation, and you can get up to like almost two times more with the newer generations.
Hmm. And then we go up and compare price again and see what we really want, right?
Yeah, so the difference between the newest generation and the previous ones is only like a few pennies per hour if you look at the
Mm.
spot or on-demand prices.
Mm. So if I'm processing a large data set, that performance difference could save me hours of compute time, which actually makes the more expensive instance only more expensive by a few cents, which actually makes it cheaper overall, right?
Yes, and we already tried to guide you with some related emojis on the top. Like you can see the cheapest instance from the listed ones, and you can see the top performant or the best value for the price.
So I should be looking for the medal, right? Or
Yes, absolutely.
this is really cool. So instead of going around in AWS and they show me there could be the most profitable instance, you're showing me the most efficient ones for my actual use case.
Oh,
Uh,
and you
mhm.
said AI project, right? So
Yeah,
instead of the memory bandwidth or one of the many other benchmarks, let
token.
me scroll down to LLM inference speed. And last time I think we used the gamma model. So let me go
Mm,
with that again. So looking at the R6, you can see that you get like 2.5 tokens per second when it comes to text generation for short text. With the newer and the newest generations, you can get at least 1.5 more
mhm.
uh, for pretty much the same price.
In addition to LLM, and say that I'm not an AI engineer, what can you use this to benchmark? You can use it to benchmark for any purpose of applications.
Yes, we have a pretty wide list of benchmarks running. There's one for web serving, database performance, image processing, compression, whatever your workload needs. We have, I think, a similar benchmark already implemented.
I hope by this point you are convinced about SpareCore like I did. Gergely, can you tell us more about the project?
Of course. So SpareCourse is fully open source and you can go to sparecourse.com right now and try it. We are not selling you cloud services. We are here to help you buy them intelligently. Whether you are running AI inference, data processing, or honestly any cloud workload, we show you the real performance and cost efficiency that cloud providers might not be showing you right away on their console.
Mm-hmm. Gerge is being modest. In short, the business model doesn't work, right? If you try to pick instance on cloud console from the cloud providers, they are more incentivized to show you what they want to show you, their most profitable instance. So start making data-driven decisions on your DevOps and AI ops. You can also find good deals for other clouds as well. Today we're showing AWS, but you can also find GCP, Azure, and many more cloud providers deals on our platform. Your manager will love the cost savings, and your engineering team will love the performance improvements.
Indeed. That's it for today. Please subscribe to get more deals and some spare course tricks. Thank you.
Thanks everyone. We'll make more videos for you and happy saving. Bye bye.
Bye.